Alrighty, so today's lesson will be on solving systems of equations. You'll have two unknowns, an x and a y typically, because you might remember doing this in Common Core Algebra 1, a little bit in geometry, Common Core Algebra 2 a teeny bit, and then we did it a little bit in the beginning of IB Math 1, because these are very predominantly on the SAT, big time. Anyways, most of the time you're solving two systems equations, you're looking for variables x and y, or it could be a and b, just two different unknowns. So the substitution method, let's look at example number 1 from the worksheet. 3x minus 2y equals 6, and y equals x minus 3. So it's a multiple choice. One of these four choices is your answer. So for number 1, I'm going to use substitution. And the idea with substitution, you're going to take one equation and plug it into the other equation. So do you notice here y was set equal to x minus 3 at slope-intercept form? We're going to plug this in where we see the y. I'll use my pen, it'll be easier to see. So if I make that substitution, 3x stays minus 2, but then you have to substitute in place of the y, the binomial x minus 3. And what you'll notice here equals 6. You now have one equation to solve, and you're going to solve for the variable x. So when you do so, you'll have here, let's see, 3x, distribute the negative 2, so negative 2x. Negative 2 times negative 3 is positive 6 is equal to, 6, interesting. So we're going to get here 3x take away an x, 3x take away 2x and x is left. Subtracting 6 from both sides, you'll get x equals 0. So now you have the coordinate 0. We just need to find the y that matches it. So you eeny, meeny, miny, mo. This is an easier one. Substitute in 0 for x, you'll get 0 minus 3, making the y value negative 3. So again, that's the substitution method. That was example number 1. Number 2, another example. Beautiful. Set up for substitution, because what you'll notice here, the second line is ready to go. So I'm just going to plug in x plus 3 where I see y up in the top equation for example number 4 from the worksheet. So 3x plus 2, parentheses, so we're going to have to distribute, equals negative 14. So 3x stays put, but we have to distribute the 2. So 2 times x is 2x, plus 2 times 3 is 6, equals negative 14. Combining like terms here, I have 5x plus 6 is equal to negative 14. You want to solve for x, so we're going to subtract 6 from both sides. So now you'll have here 5x is equal to negative 20, and when you divide both sides by 5, voila. The answer we arrive at for x is equal to negative 4. So if you want to write it as an ordered pair, you're fine. You could also write x equals y equals, correct? You might remember those days. So now we know x is negative 4. Doesn't matter which equation you substitute it in. This one's obviously the easier one. If you substitute in negative 4 for x, negative 4 plus 3 will give you the y value, negative 1. So that's your point of intersection. Now we're using the algebraic method. It's called substitution. It's a fan favorite. People love this because you don't have to worry about graphing. Could you imagine changing 3x plus 2y equals negative 14 into slope-intercept form? You have to move 3x over, then divide everything by 2. But gosh, I mean, it's definitely doable on graph paper, but sometimes when that happens, you might end up with a tricky y-intercept, right? And the rise and run will work out nice, but it's the y-intercept. Or just plug into the graphing calculator. Most of the time when you're solving you have a linear system here, most of the time you will find a point of intersection. But there are some instances where there are no solutions, and that's also known as inconsistent. So what happens, if you took the time to graph, the two lines end up being parallel. You might remember that from Common Core geometry. So like for instance here, this is example number 9 from the worksheet. 4x minus 2y equals 1. I'm going to substitute this y here into the y value here. So I'll end up having 4x minus 2 has to get distributed to the binomial 2x minus 7. Still equals 1. So here, keep the 4x on hold, but distribute the negative 2, so you'll have your negative 4x. Negative 2 times negative 7 is positive 14 is equal to 1. But look what happens to the x's. They cancel. So now you're left with 14 equaling 1. Now, that's not supposed to happen. I have one pen in my hand. I it would be kind of silly if I thought I had 14, right? So there's no solution there. So if you took the time to graph these two equations, they will be parallel. So they are known as inconsistent. The other scenario, what if you have many solutions? So the lines are actually one and the same. We call that dependent. So the final example here would be number 7. So this one I wanted to show you is really interesting. You don't always have to substitute for the y. Like, take a look at the top equation. It would have been a whole lot easier if you just plugged in actually the x. So see, if you move the 4y over, you'd have another equivalent equation, x equals a minus 4y. So I would substitute that where I see the x here, making it negative 16y equals 4 times a minus 4y, close up your parentheses, minus 32. So you can solve for the other variable. So don't figure it's always going to be x. So over here on the left, I'll leave it alone, negative 16y, but I'll distribute the 4, it gives me 32. 4 times negative 4y is negative 16y minus 32. But look what happens. 32 minus 32 is nothing. So you're left with negative 16y equaling negative 16y. If you want to add 16y to both sides, you go to the final step, you end up getting the left and the right equaling. When that happens, you have many solutions. All real numbers work, and that implies that these two equations are dependent on one another. And if you graph them, they'd be one and the same. Hopefully, these 4 equations, or examples, will help you. And it summarizes what's called the substitution method, where you take one equation of the two and substitute it for the other. Key is you want to make sure one of the equations has the variable x by itself or the variable y by itself. Thanks.